We're moving on to chapter 5, which is analytic trigonometry. And so we're just going to take what we know about trig and take it one step further and analyze it. And so I want you to either print out these notes or take notes on your own paper. And I also want you to find your unit circle, or you can just Google unit circle like I did and use a Google Images. That's not what I want to do. Just so that I have it to reference it, so that I can use this information. So the first thing we're going to do is kind of explore here sum and difference. So that just means I want to be able to find something like the sine of 75. So is it just as simple as taking the sine of 45 and adding the sine of 30? Well, let's see. When I take the sine of 45 and I add the sine of 30, I get 1.207. And when I take the sine of 75, I don't get that. And so what that means, the short answer here, I'm just using decimals so that this didn't take too long. The answer is no. These are not the same thing. So it's actually a little more complicated. If I want to find the sine of 75 degrees, I am going to use the fact that 75 is 45 plus 30, but it's not just as simple as saying the sine of 45 plus the sine of 30. It's a little more complicated than that. And so what I have written here are the formulas. So for two angles, alpha and beta. So instead of x and y or a and b, they just use alpha and beta. And so if I want to find the sine of 75, so I want to find the sine of 45 plus 30, I would use this first formula. So I want you to take a minute and pause the video and write these down somewhere, so then that way you don't have to keep rewinding. I have them written down to the side here, so I'm not going to be scrolling back up. I'm just going to be using what I have to the side. Notice how the cosine of two angles added together, that's not written wrong. I made sure that these are written correctly. That is subtraction in the middle. We are not going to prove these identities or find where they came from. We're just going to use them in your own time. You are more than welcome to look into how they developed these formulas. We're just not doing that in this video. So if I wanted to find the sine of 75, I could. Or example 1 here says find the exact value of the sine of 15. So the fact that it says exact value means that the answer they're looking for is not 0.2588. That's not what they're looking for. They want me to use these formulas and they want me to find the exact value. So the first thing that I need to figure out, how can I split up 15 using something that I actually know exact values of from the unit circle? So what two angles could I use either by adding them or subtracting them that combine to make 15? And you actually have a lot of options. I'm going to choose 45 minus 30. So that's the first thing that I need to be able to do. I need to be able to find either the sum or the difference of two angles that combine to make the angle I'm looking for. So by finding the sine of 45 minus 30, I am finding the sine of 15, but I want the exact answer. So I am going to let alpha equal 45, and I'm going to let beta equal 30. And I'm going to use the sine of alpha minus beta. So the sine of alpha minus beta is equal to the sine of alpha, so the sine of 45, times the cosine of beta, so the cosine of 30, minus the cosine of alpha, which is the cosine of 45, times the sine of beta, which is the sine of 30. And I'm going to use my unit circle to find exact values. So if I do, let's see, 45, the sine is the y coordinate, the cosine is the x coordinate. So the sine of 45 is root 2 over 2. And the cosine of 30, the x value for 30, is root 3 over 2. Minus the cosine of 45, which is root 2 over 2, times the sine of 30, which is 1/2. So I'm going to combine here. Root 2 times root 3 is root 6. So this might be some refreshers with your root properties. And then 2 times 2 is 4 minus root 2 times 1 is root 2, and then 2 times 2 is 4. And so you're only allowed to add or subtract roots if they are the same underneath. So this final answer is the square root of 6 minus the square root of 2 all over 4. That is the final answer for the sine of 15. So if I took, I'm going to do alpha y equals enter, and I'm going to do the square root of 6 minus the square root of 2 all over 4, I would get the same thing for the sine of 15, but they want the exact answer, which means they don't want 0.2588, they want those roots in that fraction. So it's using the formulas, and the formulas are just a little complicated, so that might be easier said than done, just using the formulas. So let's start cosine of 165. Let's start by using our unit circle to come up with two angles on our unit circle that either add to be 165 or subtract to be 165. So what I'm going to use is 120. Maybe I can't write on this. Let's see. Nope, not allowed to write on it. Maybe. 120 and 45. 120 plus 45 is equal to 165. So I'm going to find the cosine of 120 plus 45. And I'm going to use my cosine addition formula. So I think I'm actually going to give myself a little more room here and find the exact value. Okay, so the cosine of 165. So what they don't want is for you to just round and get negative that number. They want you to find the actual, the exact value. So I'm going to use the cosine addition formula, which is the cosine of alpha. And so in this case, alpha is 120 times the cosine of beta, which is the cosine of 45. I'm just using my formula. It's minus the sine of alpha, so the sine of 120, times the sine of beta, so the sine of 45. So let's be careful with our positives and negatives. The cosine of 120 is negative 1/2. Negative 1/2 times the cosine of 45, which is positive root 2 over 2, minus the sine of 120, which is positive root 3 over 2, times the sine of 45, which is positive root 2 over 2. And so when I multiply, negative 1 times negative root 2 is negative root 2 over 4. 2 times 2 is 4. And then root 3 times root 2 is root 6 over 4. But I'm not allowed to combine roots with addition or subtraction unless they're the same. So my numerator is going to be negative root 2 minus root 6 all over 4. And if I were to type that in, I would get negative 0.96, etc. So as you can see, there are going to be similarities because you're using root 3s and root 2s and over 2s, things like that, but it's different, and those are two different fractions, so you have to be careful with the order, with the alphas and the betas. And then they're going to give you, yeah, this is a long video, but that's okay. They give you, let's see if I can go back on it. Oh, no, I don't think that. Okay. So find the exact value of sine of 7 pi over 12, and they tell me that 7 pi over 12 is pi over 3 plus pi over 4. So I'm going to let alpha equal pi over 3, and I'm going to let beta equal pi over 4, and I'm going to find the sine of those two things added together, because it's addition here. So I'm going to use the addition sign formula, which I have off to the side here. The sine of alpha, so the sine of pi over 3, times the cosine of beta, so the cosine of pi over 4, plus the cosine of alpha, so the cosine of pi over 3, times the sine of beta, which is the sine of pi over 4. And then I'm going to simplify. I'm going to use my unit circle to find these exact values. So this time I'm using pi over 3. Okay, maybe not. This is more complicated than it's worth. Okay, so pi over 3 and pi over 4. So sine is y, cosine is x. For some reason, my pen works better on Google Docs. So the sine of pi over 3, the y value is a positive root 3 over 2. And the cosine of pi over 4 is root 2 over 2. Plus, the cosine of pi over 3 is 1/2. And the sine of pi over 4 is root 2 over 2. So then I get root 6 over 4 plus root 2 over 4, which is root 6 plus root 2 all over for my answer. We are going to do example 4 of these notes on this video here. Maybe if I'm not having all these technology issues. 4 and 5, and then the next video will be about tangent. Because 4 and 5 are a little bit quicker. So they say find the exact value of cosine of 50, cosine of 20, plus sine of 50, sine of 20. So they don't just want you to type it into your calculator and get the answer. They want to know the exact value. So first, let's identify alpha and beta. Well, alpha is 50, and beta is 20. And then they say determine which sum or difference formula was used. So if I scroll all the way back up to all these formulas, which one did I use of these? Which is the same setup? And so let's see. The formula in question had the cosines together and then the sines together. And so the ones that have the cosines together and the sines together are the cosine functions of addition or subtraction. And then if there's a plus sign in the middle, that means they used the cosine of alpha minus beta. So they used the cosine of alpha minus beta formula to get this set up. And so if they use the cosine of alpha minus beta when alpha is 50 and beta is 20, then they're asking you for the cosine of 50 minus 20, which is the cosine of 30 degrees, which is, according to our unit circle, the cosine of 30 degrees is root 3 over 2. So if I typed in cosine of 50 times cosine of 20 plus sine of 50 times sine of 20, I would get this 0.866. And if I took the square root of 3 and divided it by 2, I'd get the same thing. So they don't want the decimal version. They want the exact value. So they say find the exact value of the sine of 40 cosine 20 plus cosine 40 sine 20. So first of all, alpha is 40 and beta is 20. And second of all, they want to know which formula did they use. Well, the formulas that have sine and cosine together are the sine formulas. And then if there's a plus sign in the middle, that means that they took the sine of alpha plus beta. And so that means in this case, they took the sine of 40 plus 20, which is the sine of 60, which is root 3 over 2. So the final answer is not always root 3 over 2. It's whatever the final answer is there. So this video is already long enough. I'll see you in the next one.